Hi, this is Chris Robinson, Applications Engineer at Altera, and in this video I'll be going over Altera's AXI4 Memory-Mapped Bus Functional Models. The agenda for this video will be first a brief overview of Altera's AXI4 BFMs. Next we'll go into integrating the BFM into your test bench, followed by using the BFM API to control the BFMs, and last we'll talk about migration from Siemens EDA. The Altera AXI4 Memory-Mapped BFMs help accelerate the verification process by providing key components of the verification test bench. The provided BFM components implement AMBA AXI4 protocol and also provide assertion checking within each BFM. These are to replace the Siemens EDA AXI verification IP suite, which will be deprecated at the end of 2025. The following BFMs are provided: AXI4 Memory Map Manager and Subordinate, AXI4 Lite Memory Map Manager and Subordinate, as well as a Memory Mapped Inline Monitor. These are written in System Verilog and provide a task-based API. The Subordinate BFM provides a host memory component which allows memory initialization. And these are designed to work with Siemens EDA, Cadence, and Synopsys simulators. The BFMs can be found in the IP catalog under Installed IP, Library, Verification, Simulation. You'll see both Manager and Subordinate BFMs for AXI4 and AXI4 Lite, as well as an AXI4 inline monitor. Once these are configured, then you can integrate them into your test bench. There are two ways to do this. First is to instantiate directly into your RTL. The second is to use Platform Designer, and we'll go over both flows in this presentation. The last step would be to use the API to control the BFM, and we'll go over that also later in this presentation. One note is that the inline monitor is passive, so it runs in the background, continuously monitoring. The BFM configuration consists of setting up the bus widths and outstanding reads and writes and transactions. Then you can also select which AXI4 interface signals that you would like to use, and then any user-defined signals that you would like to use. So to integrate your BFM into your test bench, the first step we'll look at is the RTL flow. First thing you do is create and configure your BFM from the IP catalog. Then you'll instantiate and connect the BFM into your test bench. And then from Quartus, you'll go to Tools, Generate Simulator Setup Script for IP, which will set up all the scripts and libraries needed for the simulator. And then to actually call the BFM, you'll go to your BFM instance. You'll either, depending on if you're using the manager or subordinate, go to AXI4 or AXI4 Lite, and then go underscore MMM manager underscore interface underscore 0. And the same thing for the subordinate. And then also to call the subordinate BFM host memory, you'll just call the subordinate and then the host memory portion of that. For the Platform Designer flow, you'll configure and connect the BFM in Platform Designer. And then in PD, you'll generate test bit system, and then also generate the HDL. Under synthesis, you'll select none for HDL, as this is only simulation code. And under simulation, you'll select create simulation model and select the simulator for which you want the simulation scripts to be generated. And then to call the BFM, you'll call the PD system instance, the PD BFM instance, and then also again the PD BFM instance. So whatever names you're using for that in Platform Designer will be the names that you would use to call it. And then to call the subordinate host memory, again, you would just call the subordinate host or subordinate BFM and then the host memory portion of that. Here's just a simple screenshot of a Platform Designer system where we have the AXI4 Manager BFM connected up to the subordinate BFM. This design and also an RTL design are both provided in the documentation so that to walk you through the examples. To use the Manager BFM, the first thing that we need to do is import the Altera AXI BFM package into our System Verilog test bench. The next thing it will do is then declare our read and write transactions. Then we'll declare the Manager BFM and assign it to the BFM that we instantiated into our RTL. And then prior to use, we need to reset the BFM. Then the next step is to create and configure our read and write transactions. So there's actually two ways to do this. So the first one is that we can just create the transaction like we see here when we create our write transaction. And then we can individually configure the write transaction. So each one of the set IDs, set the address, set the burst length, the size, and the burst type. Or, as we can see in our read transaction, we can create the read transaction and configure all in the same command. And then the last thing we do is we execute our transactions. So here you can see that we'll do that by using the put transaction. So we'll put our write transaction, and then we'll drive the transaction. And the same thing for our read transaction. We'll use our read transaction and the put transaction, which puts it into the queue, and then we'll drive it. To use the subordinate BFM, the first thing we'll need to do is to include our Altera AXI BFM package and our host memory class package into our System Verilog test bench. And then we'll declare our read and write response transactions. And then we'll declare our subordinate BFM and assign it to the BFM that we instantiated in our test bench. And the same as before, before we can use our BFM, we need to reset it. Then we will create our read and write response transactions. And then if we want, we can also initialize the host memory. So we'll use the host memory initialize data and load the buffers. And the last thing we need to do is then execute our response transactions. And here we just put them in a forever loop where we have the put transaction of our read response and a put transaction of our write response, and then drive those transactions. So now we'll talk about migration from the Siemens EDA VIP to the Altera AXI4 Memory-Mapped BFMs. So for the Manager BFM, the Siemens and Altera flow are very similar, as well as the API. You can see that we have some very similar API with the set config and get config. We have create write transaction, which then over to Altera is Manager BFM write transaction, and create read transaction, which on the Altera side is Manager BFM read transaction. A couple differences though are with Siemens, there's a single API called execute transaction that is used, while with Altera, we have put transaction and drive transaction to complete the whole transaction. Also, Siemens does provide individual phases of transactions, which is not supported by the Altera BFM. Therefore, no individual phases are allowed, and that you would have to use the put and drive to drive the complete transaction. For the subordinate BFM API, we still have some similar API calls such as get config and set config. With the create slave transaction, Altera breaks those out into a write response and a read response transaction. And then for the Siemens, individual phases were provided. However, with the Altera BFM, you will need to use the put and drive transaction to drive the complete transaction. There's also for APIs of like get write address data and get read data, there's none available. And then for the set read data, we then go to host memory initialize data. For further information, I recommend going to the Altera AXI4 Bus Functional Model User Guides.